All right, guys. I'm here to talk about CoreBluetooth. My name is Guilherme. I'm an iOS developer at Mobiconf. And before we start, I wanted to mention that I was really, really impressed by the motion design presentation given by Maciek Zved. And now, since I'm a firm, true believer of motion design, I decided to go back and animate everything. Impressive, I know. You got to thank this guy for that. All right. So here's a little background on how this came to life. We had this client who wanted to develop a BTLE and classic enabled device, right? They needed to do things like playing Bluetooth music using A2DP, which is a standard profile. They wanted the app to serve data. We could have tracks. We could use a microphone to tag music. It would be a unit installed in the car, and then we would just control it with the app. So the app is mediating all these things. He's playing a central role, which you will learn what it is during this presentation. I'm going to give you some pointers of things you should know. Some of the stuff would be, let's say, basic. You could just go through the Apple Docs and read it. But I want to show you how they actually apply on the real world. I'm going to mention why this would fail or how you would structure, what you would have to plan ahead to do in that situation to, not get the most common errors. So I'm going to talk about a few of my goals for this presentation, and I hope you learn these things. So how scanning for peripherals should work, why you should mind battery usage, for instance. That's the thing that Apple stresses out a lot. Remember, you could have other apps using Bluetooth, antenna, Wi-Fi. Everything is connected, so you have to be mindful of that consumption and battery, of course. How to connect to those peripherals, how to read, write, and subscribe to the data in them, how you're going to handle it, and whatever you need to do. I need you to really understand state restoration, because you can establish a connection and everything is fine, but what happens if it fails? What if your app crashes? When the user restarts again, how do you retrieve those peripherals fast enough? How do you guarantee these things are going to happen? We're going to talk a little bit about the fact that services and characteristics can be encrypted, and this will trigger a pairing request. So if you go to your phone and you have a Bluetooth device, you can probably look into your settings table and you see there's a little I next to it, and you can forget the device. That means the device is paired. It has a key that's stored on your phone, and we're going to talk a little bit how to trigger that and what it changes, and how CoreBluetooth behaves in foreground and background, and again, to avoid the mistakes everyone would make just reading the Apple Docs and not actually, having the experience of having worked with CoreBluetooth in a real world. So, challenge accepted, and let's go. First of all, what is CoreBluetooth? Apple's framework that's abstracting Bluetooth 4.0. What does that really tell us? Look at that image. What it's telling you guys is you don't have to care about the low-level protocol stack. GATT is generic attributes profile. It's going to include the whole tree about how services have characteristics, they don't have attributes. ATT is the attributes profile. It's the single data unit from the embedded side. So they would have a handle, the UUID for that thing, and the value. And we have the logical link control and adaptation layer protocol. So that's for the data link. It was introduced in iOS 5, OS X 10.7. You do not have Bluetooth on the simulator. Now, when you're reading through the Apple Docs, they mention lots of stuff like local peripheral and remote peripheral. In our scenario here, since we had an external device, our client was developing it, we were building it together and exchanging information, it was a remote peripheral. When they mention local peripherals, is if you actually implement your own CB peripheral, and you kind of abstract that. You'll have your own. You can make your iOS a peripheral as well. So you can have both roles playing, let's say your Mac and your iPhone, or whatever it may need be. So like I said, there's two roles, and I would like you to just analyze this image real quick. It's pretty straightforward. You have centrals and peripherals. Like I said, in this case, it would be a remote peripheral, right? We're not using another phone or a Mac to connect to it. So, hey, Guy, what about Classic? You said it's BTLE and Classic enabled. Now, to handle Classic, you would have to be able to touch the external accessory framework. You can include it, you can import it, you can do whatever you want, but it won't work. Why? Because you need to be MFI compliant. That means that you will enroll in an Apple program. You have to have your company identity verified and subscribe, etc. You can read all about it on their website. And it would enable you to use the external accessory. However, for our client, fortunately, they only wanted the generic profile. So again, if you look at this image, if you will, we have things like hands-free profile. As long as the embedded side includes these things, that means that we would get calling for free. If you have AVRCP, you could get, the play, the next, the pause for free. You can browse your BT Music library from Apple Music. You can have HID, human interface device. You guys probably have heard of that when you're working with your keyboard. It connects in Bluetooth, it implements the HID, and it all works out of the box, right? Okay, so for topics, that's the topic structure. Talk to your client. Now, I can't emphasize this enough because it's been a wild ride. We were learning how to work with Bluetooth, and they were learning how to work with Bluetooth. They weren't too sure of what they were doing, and we wanted to explore the capabilities and the limits of what we were trying to achieve. Now, the first thing, we'd have to differentiate the products, right? We had to have a way to say, okay, who's the manufacturer, what's the model, what are its capabilities? I'll talk about that. We've had that talk. The formats, how we would exchange with the services and characteristics. So what to expect, what to send, how to structure them. Over-the-air upgrades, that's a pretty cool thing. We can have a file to upgrade the embedded device. So that's another thing we've done. Keep the connection alive, the ping. Now the thing with the ping and keeping the connection alive is Bluetooth Low Energy was meant to be some sort of, you connect, you deal with your device, and you disconnect, right? It's supposed to be fast, quick, easy, low energy. In our scenario, it would always have to be running because our use case would say you're driving home and it could take an hour. And even though you're not using the device, if you come into range with it, it will automatically connect. So your app is running in the background, it restored, and it connected. So everything is set up. That means that if some cool song pops up on the radio, our user can just press a button and he can tag that track. And it all needs to be ready and available for him at any time. In other words, he's always connected and the ping is always running, right? So we work a little bit differently, but we try to minimize everything in that sense. Error detecting and handling. Okay, guys, you've probably had someone say, I want the solution to be robust. It should handle errors gracefully. And when we're talking about, robustness and error handling and failing gracefully, in other words, what we mean is if something goes wrong, we want to know what it is, we want to let the user know what it is, and we want to tell them how to fix it. So I'll talk a little bit about that. Documentation is key. We've had hours and hours and hours of talk, and as you know, if you don't plan, you fail. Planning is success. And we had to document all these things. We have a very neat, organized BLE API structure documenting all the UUIDs, all the services, all the characteristics, how they should be interacted with, what could change, and what not. So this is very important. And it might seem obvious that I'm showing this to you right now, but if you went through what I went through, you would understand that this is very, very important. So it's there. All right. Let's talk about the central. So there's this little guy called, CB Central Manager, and he's the guy who's going to be scanning for peripherals, right? He's the guy responsible for discovering, for connecting, and whatnot. So how do we initialize him? this is the piece of code. It's pretty obvious. And the first thing I would like to point out is you see I'm creating a manager queue right at the very beginning. Why? If you follow the docs, you would just include this and it would give you, init with delegate self, queue nil, options nil. Why? Because you don't care. You just want to get there. And as you work on your project, you're happy and you would be following along. And down the line, you would be trading information and everything is running on the main queue. And then you're just like, wow, when I'm interacting with your device, everything is blocked, right? It's a very common mistake. It's basic, but I wanted to point that out because lots of people ignore it and then they have to come back to it. So don't block the main queue. Just create a new one and, have the commands run on a separate thread, and that should be fine. Understanding the options. Now, you see here, I've specified two options. I have the restore identifier key, which is very, very, very important. This means, by Apple Docs words, that you're opting in on state restoration. In other words, if everything fails, if your app reruns, and you have to bring your state back or know what was going on, this is the guy responsible for doing it. And he has a key why. You could have several central managers. So we're telling you that this guy is ours, is the one we want to use. And for our use case, we only had to have one. So that key never changed and everything is working fine. The second thing, it would be the show power alert key. Now, this would just say Bluetooth is turned off when you initialize the CB Central Manager, right? And you would say, hey, what's the problem with that? Well, the problem with that is usually if you want fast reconnection, where would you initialize your CB Central Manager? Right at startup, right? But then you would get that dialog telling you Bluetooth is turned off for some reason, because it is. And you would say, okay, now it's blocking everything. However, it seems obvious if Bluetooth is turned off and you get the dialog. What I'm here to tell you is if this is turned on, sometimes, even if Bluetooth is turned on, you will start your app and you will still get that dialog. You would get an off and then an on, like in transition. And then you would have Bluetooth turned on, trying to reconnect, and everything is blocked. You don't want that. Continuing about that. So now we have the central manager, and we would like to do product setup, right? That's very basic. We'll have to have a table view. In our case, we had to distinguish the products. So we're talking about you discover 100 peripherals near you. And some of them are device A, device B, device C. They have different models. You don't have to show them all. You just have to know which one you're setting up. And then you can narrow it down. So we have a central, right? How do we scan? And that's going to be very important. This is how you scan. Pay attention that I explicitly have alpha and beta product. We specified this with the UUIDs during the documentation that this is how we would scan for. Most people, if you're working with, let's say, a heart rate monitor, you scan for the heart rate service. It's under the Bluetooth SIG. It's already, industry standard. But it wouldn't make sense. I mean, it would if this were your use case. Why? In other words, you're telling me that you want to scan for everyone who can read heart rate, right? So you're not telling me it's device specific. You're just looking for a general service. In our case, we first have to look for the product, and how we differentiate them is about the services. So the product itself has to have a service to identify who he is. And that's why we've done that. And we're going to face here our first battery issue. Why? You see that on the options, I have allow duplicate keys. What this means is it will squeeze all the advertisement data into one. There's a callback called did discover peripheral, which will only be fired once, like for each new peripheral. You don't want it to keep repeating. I mean, for me, it made sense. For you, it might not. You can do other stuff with it. You might need to advertise all the time, use the RSSI to determine proximity. You want to triangulate. I don't know. It depends on your use case. But if you're working with one device, I assume it makes sense that if you want to set it up and you want to have it, you discovered it, and you only want to get the advertisement data once. You store it and it's there. You display the information, period. I don't even have to go into the battery drain because the advertisement intervals, sorry for that, the advertisement intervals from the embedded side could vary from 20 milliseconds to 10.64. So what you're telling me is, if the guy on the embedded side is like, okay, let's start with a very fast advertising rate, and you just scan nil, I want to have everything, I don't care, I'm not going to specify. You're searching for everything near you, no matter what it is, everything that has a Bluetooth advertisement mode, you're scanning for that. You're getting all these callbacks, and you're putting a lot of strain on the antenna that way. And your battery is going to go really quickly. So be mindful of that. And Apple will always remind you to be mindful of that. So you can see here, I'm scanning for 2 peripherals with those services, right? On production code, never do that. Like, please. Like, I haven't found one single case where it would make sense for you to specify nil. Why? Because, like I said, you're going to look for every single device in range. So to me, it doesn't make sense that if you already know what you're looking for, you're going to say, notify me about everyone in my range so I can pick someone out. Right? It doesn't make sense. Okay, continuing on. Now we're going to start discovering. And now we know there are some hot single peripherals near you, huh? So let's get on to that. How to handle the discovery. Since we don't allow duplicate keys, this is only going to be fired once, right? For each new peripheral, which is, again, fitting our use case. And then you can go. The first thing I would tell you about this whole structure here is pay attention where I check if this discovered peripheral is already there, if it's already on the discovered peripherals. Why? This is going to keep a strong reference to it. And a lot of people, again, this is not in the Apple docs, and it's something that a lot of people, let's say if you go to Stack Overflow, it's got way too many views for something so simple. Why my callback delegates don't show up for the peripheral? I connected to it, and I don't get notified. Why? Because you have to keep a strong reference to it. Internally, the central manager won't keep that reference for you, so you have to do it yourself. Another thing that you can do here is talk about the naming and the identifier. Those two are very, 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 very important. Why? In our case, we had to have a PIN code to set up. And again, we decided that the best way to do that was included in the name. So we would have device 1234, and that would be its setup PIN code, right? However, peripheral name, as you can see in the example, is nil. Why? This is the same reason as when your Bluetooth device is advertising. You can look on your pairing table. Sometimes it says unknown, or it could just use the default value, let's say generic audio device. This is the same reason, right? And the identifier is a seed algorithm that will be generated by the CB Central Manager and the OS internally. And people have tried to figure out how it works. But the long story short is, it's the only thing you can keep as a real ID, right? However, there's a caveat here, which I'll get to it in a second. You also should know the identifier is NSUUID. It's usually what you would store for restoration, so you won't be able to store it that way. You would have to use it as a string. And if you have a different central, it would give you a different identifier. This is very key. Like I said, I only had one central. If you have two, that means that for the same peripheral, you could have different identifiers. That's really, really important. If you discover something, you're discovering, you're exhibiting all that, but then a few of your devices, maybe all of them got powered off, and you would say, how would I, discover that? How would I find that out? You don't. What I would say is just do a periodic check, stop the scan, trash everything, and scan it again. Don't bother trying to keep that difference going or checking that out. That would be too much work for too little benefit. And why am I only checking one service here? It's because of the pairing and the caching. It wouldn't make sense if you don't know if you can if you're even allowed to, mess with that device to discover everything. So first what we do is a probe. It's a check. Like, can I hit this? If I can hit this and I have the keys, I'm able to pair with this guy, I'm able to read his values, write values to him, then yeah, I'll get the rest. So moving on, advertisement data. That's one of the things that was coming from the skull here, if you pay attention to it. And you remember I said the peripheral name would be nil, right? If you look here, there's two special things I want to point out. On the embedded side, when you do scan for peripherals with service and you specify the UID, this guy here, service UUID's keys, 1, 2, 3, 4, the fourth one, that's going to be the guy who we're looking for. And if you don't specify it, it won't work. And the first one, the local name, it would be where you actually store your name. So again, back to my example, peripheral.name could be nil, and it will probably show, I don't know, generic audio device, generic keyboard, generic HID, whatever it may be. However, this guy, and we show him here, it would always tell us the truth. So device 3657. So you want to rely on that one instead of the peripheral.name. Okay, so this would be useful identifying for a pin code setup and that kind of stuff. So Houston, now we have a connection, I guess. And what's the first thing we do after we're connected? Stop the scan. Like really, I'm not kidding. Battery issues, guys. Mindful of radio usage consumption. After you stop the scan, I want to point out that the name could still be nil. Why? We're connected. We know everything about this peripheral, yes, but it won't be updated. There's no explicit API to force refresh the name on Bluetooth. Again, don't rely on peripheral.name unless you have some good reason to, but I can't tell you one. And I'm only discovering one service, again, for faster discovery. So if you look here, I'm also storing it on user defaults. This is for the state restoration. I need to know what was the identifier that was used so I can opt in on that, right? The 180A that you see there, it's pretty small. Like if you compare with the product ones, you remember, they were pretty long. This is specified by the Bluetooth Special Interest Group, and these guys have those reserved services and characteristics. This one is for device information. It contains things like software revision string, user model, and what other things. You can check it out. So now we're going to try to discover these services, right? And we have the peripheral now. Yay. So after we connect, first thing you want to do is check for the pairing. Why? Our device wouldn't work if you don't pair it. It just won't. It doesn't make sense. It has to be a protected setup. Here we're checking for if it's paired and if the device, if the service belongs to the device information family. Now, pay close attention that we want to discover just one characteristic again. There's no need for us to go to all of them because we're only trying to hit once. And if we already are paired, you can just discover every single characteristic. Seems pretty straightforward, right? What happens if it's cached, though? You're thinking, okay, every time I did discover services, I'll check for the pairing keys, and I'll do this, and I'll do that. What if you don't get that? And this is what happens, let's say, if you can fully connect to a device once, and then your user forgets the key on the phone, for instance. Now, you would connect, you would be able to do everything, but you're not going to get did discover services. When you're trying to discover, let's say, the first service to know if the pairing key is there, it would just say, hey, man, I have everything cached already. I'm here for you. And you won't be able to do anything with that, which would be terrible. So my advice, just throw it away, cancel the connection and connect again, or I will show you how to figure out the whole key scenario. Are we connected? So we got the did connect peripheral. We can check into the peripheral state. We can check everything, but it's not fully connected, not to me. Why? We need the pairing keys to be useful, right? And how do we get that to fire? The embedded side is the one that actually triggers the pairing request. you have to tell the guy on the hardware side to send an insufficient authorization request every time he tries to connect. So here, if you follow this, it will trigger the embedded side. We're trying to discover, we discover the characteristics, and you see that when we compare against 2828, that's the software version, we're trying to read its value. And then what's going to happen? It would be we're fully connected. Why? Because if you get an error on this callback, this is what I was mentioning. If you get an error on this callback, it means that you don't have enough authorization. I already wrote it here, pairing request rejected, update the UI, right? If you don't, that means you actually got the keys. This is important. This is important. I really don't want to speed through this. Why? Because you can't check the pairing state by yourself. We have no access to what's on the settings Bluetooth menu. So what you're telling me is, Guy, every time I'll have to connect to the device and basically ask and try to interact with the device, you know, if I have the keys, if I can do it, if I can't do it, yes. You can't just say, I know this guy, like I have his keys. No, he will tell you. So it's sort of push and pull. You have to be very careful with this scenario. It's going to make you pull your hair out a few times because there's too many branches. Now that we're fully paired and we have the pairing request, we can discover the rest of the services, right? So we'll just go back to that. We set is paired to true and everything would be fine. However, when you're discovering the characteristics, which was on the previous slide, you want to make sure you keep a reference to those characteristics. So a characteristics dictionary or whatever data structure you want to use. Why? In my case, I get all the characteristics associated to, let's say, writing to the device's screen, manipulating the icons on the screen, and I give it to a write device manager, a write screen manager. And then this guy will know everything he can do. So that's a bit of a way you can reduce the bloating of that code. Here, you can also see that I have write with response. On the previous slide, I was supposed to talk about the writing with response. It's if you write with response, you are allowed to write more than if you do it without. That's because you have the pairing keys and it just allows you to push more data. All right, so now we have the connection. When I was talking about all these things, I but I omitted the did update state. Why? This would normally be the first thing you would look into and say, oh, I have to tell my user Bluetooth is off. Oh no, I have to tell him to turn it on. And now I have to start scanning. Yeah, that's all fine and beautiful. But the real trick here and why I'm showing you this in a separate slide is, by Apple Docs, what they will tell you is if anything goes below powered off, all the CB peripherals objects are invalidated. What does that mean? In other words, it means that even if you have everything set up, you have 6, 7 devices discovered, it's all set up, you got all the identifiers. If something happens, now resetting is when the Bluetooth stack crashes. That's by my experience. It's not actually documented. It doesn't say exactly how it could happen. But from what I've seen it happen, if you overload it, it could crash and it will tell you resetting. So that means that everything you stored, all the guys you were connecting to have to be rediscovered. They have to be updated, all the references. Unsupported, it's pretty obvious. I mean, if you run on something that doesn't have the LE, you wouldn't even be able to get the peripheral in the first place. But yes, it would be invalidated. Update the UI with the states, that's pretty obvious. Perform cleanups and start-stop scanning. That's when I said, you know, Bluetooth from on to off to on, and they get invalidated. Now, a few things that I want you to keep in mind here is Central is the one that manages all of the connection, right? Like, Peripheral doesn't know if he got connected or not. And I'll also get into that in a second. Why is this so important? First of all, Connect Peripheral never times out. So that means that if you start your app, you've done state restoration, and you fire that call, it's going to say connecting. And it's going to stay like that forever. like forever. Your app goes to background, it's still trying to connect to that device. The reason for that is there's a little user scenario for state restoration, which is if you have a lock and you are connected to it, and let's say every time you get in range, it opens, and you walk out of range, you would get did disconnect peripheral, right? Then you go to work, and let's say your app crashes or he closes the app. Now, it would be trying to connect, and if you came back, if the app hadn't been closed, it would just connect instantly and open the door for you. But hey, the app crashed. So you don't have it anymore. You don't have that connection request anymore. So it will never time out, like I said, but if you don't do the state restoration, you will see that it would be a mess. You wouldn't be able to get into your house that way because you don't know how to fire that connect request anymore. The physical connection is different from the logical connection. Now, what do I mean by that? On this example, if it was an encrypted characteristic, let's say the lock had to have the pairing request, it's stored under your settings table on the Bluetooth. You walked out of range and you walk back in. It will automatically connect, no matter what. However, it will only physically connect. What this means is if you look at it and you press it on the settings table, it doesn't mean that your app can do anything to it. It didn't discover the services. It didn't build the characteristics dictionary. It didn't do anything. Even though they're cached, if the logical connection inside the app is disconnected, it does you no good. So we're lying to our users because multiple times I've had someone say, I don't believe you because it says right here, it's connected. Yes, but if you look inside the app, it will say disconnected. And then you're like, okay, how do I manage this? Because I can't know if it's physically connected or not. I can only know if it's logically connected. It will be a leap, so I'll show you that too. Cancel peripheral connection only cancels the logic. So again, I'm going to explain this in a few with the disconnect button. So I'll leave this for now. I'll skip it. It doesn't guarantee the physical disconnect, like I said. There's also one thing. When you do call cancel peripheral connection, it will give you did disconnect. But it doesn't tell you why, right? I mean, if you called it, it doesn't need to. But if you walk out of range, you don't know you disconnected because of that. And of course, someone will always tell you, again, you have to handle errors gracefully. If you walk out of range, I want to tell the user, you walked out of range, you just got disconnected. You can't do that. You don't know. There's no differentiation there. For pairing required connections, how we did it is when you're setting up, the OS will fire the pairing request for you. You don't know when it shows up, and you can sort of figure out when it goes away, like I showed you on the update value characteristics. So what can you do? If you don't answer it, it will disconnect in 30 seconds. Every Bluetooth device, if you connect to it and it requires a pairing request, it will disconnect in 30 seconds. So that's fine. However, you also have did fail to connect. So I've been talking about connecting, disconnecting, walking out of range, and all these examples. But what about did fail to connect? That would be the example that would happen if you forget the keys on the device and then try to connect to the peripheral. Now, the peripheral has the keys. He's going to accept anything you do to it, but the phone doesn't. So how does it work? He's going to connect. He's not going to get an error. The device is accepting everything you do, but for some reason it keeps pushing you out. That's the guy who you're going to get. Did fail to connect. And that's really important because you can't assume, again, this is a very wild area. You can't assume because you did fail to connect that you don't have the keys. So you see, it could be cached. You could just not have the keys. Too many things could happen for you to just react to that. So again, you have to know what you're doing and you have to plan ahead. You have to say, okay, what error message are we sending or how are we handling this from the embedded side to us? We have to figure out a strategy. A few considerations again. We had the disconnect button on the settings page and it took us a while, more than I like to admit, to figure out that it doesn't advertise again. Why is that? If you're thinking about, I have a connect button and disconnect button in my simple app. If you have a paired device, if it requires pairing, it doesn't really matter. Like, just don't. Why? Not because I said so, but ideally, let's say you have two people. I have this device set up here, and I'm gonna say, okay, I don't want to use it anymore. I'll disconnect from it, and now you can set it up. You can be a second user to it, or I'm giving it to you. It doesn't matter. So my Bluetooth is turned on, and I said I want to logically disconnect. That's what cancel peripheral connection does, right? But it's not physically disconnected. So no matter how hard you stare at your screen, you're not going to get the did discover peripheral on the second user. And you will be thinking, why? Why? It doesn't make sense. Because I don't want to forget mine. It's still my device. I could be the first user, you could be the second. So basically, these kind of things, just turn Bluetooth off. Really. Unless you have a way for embedded to disconnect from you, or you can send some sort of request that it disconnects from you. For our use case, it wouldn't make sense, but you could do that. You could say, okay, when I try to cancel, I'll first send you a request, and you disconnect physically from me, and the app will logically disconnect from you. It seems a lot, and it is, but that's how it's meant to be done. How to remove a device from the product list then, if you can't control these kind of things? Let's say, in our example, we have your products and set up a new product, right? So on your products, what would you do if you still have the pairing keys? Like, I want to swipe to delete, and you delete that device. But okay, you didn't cancel. You could cancel the logical connection, but you're still physically connected to it. No one else can do anything to it. It's never going to go away from you, right? Unless you forget it on the settings table. So you're thinking, okay, Guy, the same thing to do, in my opinion, would be if you're really dismissing it and you never want that device again, make sure you tell the user to forget it on the settings table. And yeah, I mean, that's the same way. To me, it's a bit awful that you have to force the user to do that, but you have no control over it. So it seems to be the best way so far. When user walks in out of range, like I said, you won't be able to detect this. You just get a did disconnect, and you have to live with it. Now you have to plan ahead. You can do some sort of new tricks. You can look for RSSI, try to determine proximity after he walks out of range and say, okay, he was on the borderline, and try to assume some stuff. You can try to be clever there. If the device goes to standby. Now, when our device goes to standby, it kills the BLE and the classic connection. And now you have to think like, okay, can I know if the device is on standby? Because one of the things that was talked with our client is we want to show when he's on standby or it's not in range or whatever. And how would you detect that? Because for us to detect that, BLE would still have to be enabled, and he would have to say, I'm going into standby. And then you would have to have a wake up. So again, there's too many branches that you have to plan ahead for in this kind of scenarios. You really have to just sit down and talk and agree on a bunch of stuff. Connection timeout. Like I said, connection never times out. Now, yes and no. What do I mean by that? When you have your products table, you tap it, and let's say your device is coming out of standby mode, it's initializing the CPUs, it's going to start advertising BLE, and it's going to connect classic. I mean, you have to have a limit, right? Like, let's say you tap that cell, and it takes 30 seconds, but let's say it's still starting up. It takes longer than 30 seconds. So you have to make a call. Like, you're going to say it failed, it didn't connect, and then you're going to try to cancel it, or what are you going to do, right? So this is very tricky. And I can tell you, one of the borderline scenarios would be you tap to connect, you wait 10 seconds. When 9 seconds have passed by, it fully initializes. So now 10 seconds, you're ready to say you could not connect, it's going to fail. But since everything is powered on and you're in range, we have a paired device. It will automatically connect to it. Not logically, physically. What does this mean? You just hog the device. No one else can use it. So you're in a weird state right now, and you have to figure out how to get out of it. So these things can be very challenging. There is a way to sort of get around that, which is checking for retrieved connected peripherals with identifier. I'm going to talk about that in state restoration, but I just want to show you how many problematics you can face here, so then I can sort of alleviate the pain for you later on, or try. Cached services and characteristics. This could happen when you upgrade your device, for instance. On the embedded side, the guys updated from R2 to R15, and what happened was they shifted the handles on the ATT profile. Now, when that happened, it meant that when we connected, everything was fine. We have keys, they have keys, everyone is happy. But when we went to use any of the characteristics, boom, nothing worked, trash data, even crashes, because you weren't ready for it. We had agreed on a format, and now it's different, right? The other thing about the caching, there's no explicit documentation how to get rid of it or how it would work. So what you would have to do is turn it off, turn it on. It seems sad, but it is. That's, at least, I've talked to a lot of people about this, and that seems to be the only way to get rid of it. You will have to turn it off and turn it on again. Like, it doesn't matter. You don't want to destroy your peripheral. You don't want to tell the user to reset up. Obviously, I think the cost of turning it off and on, you know, it takes 5 seconds to reset it up. It might take a long time in your device. I don't know. If the user forgets the connection, like I said, you can't detect that. Let's go to state restoration. Now, this is a bit of the heart and soul of working with CoreBluetooth. This, I spent too much time looking at this and thinking and planning, really. Because here you can see that what Apple advises us to do is first try to retrieve the connected ones. What does this mean? As soon as you start up, Central Manager can check for devices who are connected. Again, they can be connected in our case, for instance, but they might not have the keys. So again, does that tell you something? No. Okay, you found it, you didn't, then you try to retrieve known peripherals. Known peripherals means that you've connected at least once to this guy and it's on the internal database. The only way to get rid of these identifiers and that kind of stuff is to flush the network settings. There's no other way around it, right? So moving forward here, remember when the peripherals get invalidated? We had those little states for CB Central Manager, powered on, powered off, unsupported, unauthorized, resetting. So when that happens, these guys are the ones who are going to bring us up to speed, right? What we're going to do is, if we detect that state change, we're going to go back to every reference we had for that peripheral, and we'll retrieve it, and we will replace it. And we'll have to build his dictionary again, all over, everything. So you can see for the example code, there's a key called Launch Options Bluetooth Peripheral Keys. This is done in the did finish launching, and you can just look for that. I'm showing you. You have to do an NSUUID with these guys. They will just be plain strings, and then you can just retrieve them with the identifiers, like I'm showing you on the code. I don't have to get too much into that. Here is the will restore state. Now, you have two ways of doing it, right? They can all get invalidated because of the state change, or your app, let's say, can have a soft reset, a crash when it's in background mode. And when you fire it up again, instead of trying to do everything from scratch, you will get this guy. Why? This is why we set the key on the restoration identifier at the beginning. This guy will say, what happened when, let's say, the app crashed? How was the peripheral? Was he discovering what services did he have? What characteristics did he have? What were we doing? What was the state? And this is very, very important, right? This guy is very important to rebuild all that scenario. So, you kind of have to tinker with these things. You have to figure out how it's going to go. Again, it's widely variable depending on the use case and how you're going to work with your client. If you're going to have multiple centrals, if you're only going to have one peripheral, if you can have more than one peripheral. One thing that happened to us was, we set up one device. And then we had to set up another device that had another version, and we wanted to change between them. Let's say, oh, device A can do this, device B can't do this. So we're just playing with them. But remember, when you're connecting to it, you're physically connected and logically connected. So now you have 4 connections because we had 2 BLE, 2 classic, and then mayhem is just mayhem. You can't cancel the peripheral connection because that's just logical, and there's still an overhead of connection. All right, and I want to explain a little bit of how your app is going to work in foreground and background. Now, in foreground, when you start scanning, you can do it restricted with service, right? You can do it unrestricted if you pass nil for scan for peripherals. Don't do that. Don't deploy with that, please, if you absolutely don't have to. And you can check for the duplicate keys. So remember when I said we would only get one did discover peripheral call? Yeah, so this is the guy responsible for it, and he will be respected if you're in foreground. Now things get a little more bumpy when we go to background. Unrestricted is canceled. You cannot have a nil, scan for peripherals nil running in background. It will completely be ignored. If the duplicate flag is set, it will be ignored. It will only work for new devices. So what this tells you is, even if you set allow duplicates to yes, you will only get the first did discover peripheral for each new device in range. I don't want to skip just yet to, there's some reading part. I think there's a few considerations that we could still make. Guys, I've had lots of problems with connecting and reconnecting. I can't stress this enough. When you're dealing with the services and characteristics, eventually it gets easy to wrap your head around it. Why does the trigger, how to trigger the pairing request? When does it show? What can I do about it? And you sort of have to accept the limitations that are there. And you can't get around it. You can be clever about it, but you just can't get around it. But with connecting and disconnecting and understanding the fact that something is physically connected, but it's not logically connected, this causes a lot of confusion. And you have to be very prepared to talk to your client or explain or implement your error handling or whatever feedback screens you're going to give to your user on why and how. Because this is going to take a lot of effort. Trust me. And I want you to prepare ahead for it. And, some reading now is definitely look at the 2012 WWDC. These guys will tell you everything you need to know. They touch a little bit of the caching mechanism, not how it's done, but just that it's there. So basically, no black magic. Also go for the Bluetooth SIG. This is where you go to if you want to know all the standard services, like I showed you, the device information. Yeah, and I guess, I hope I achieved most, if not all, of these goals. I know it's a lot to talk about. It might have been a little sped through. It might have been too deep or too shallow. But again, I can't show you something too elaborate if I don't know your use case. I don't know your situation. I don't know your scenario. Again, what we had was just one user, one central, one peripheral, and we had to deal with it. We just wanted fast reconnection. The connection never times out. We always have to be ready. We walk in range, you do it, you serve the user. That's it. Again, mind better usage, mind radio consumption, and be smart about your choices when you're specifying all that kind of stuff. So, that being said, I guess we can wrap it up and go to QA. So, anyone got questions?
Hi, thank you for your presentation.
You're
I
welcome.
have one question. In Bluetooth low energy communication, there are some strong limitations about speed of communication. There, if I'm right, there are 4 kilobytes per second. Is there any way how to speed it up, or
No.
I have to use some other technology?
No, there isn't. It's limited because by the Bluetooth spec, those are the data rates they're supposed to comply to. And not only that, let's say when you're writing values, you're pushing stuff to the device, you can't do it, let's say, like in Android. You can't control how it's going to be pushed. You can prioritize a packet or something like that. So it's going to queue internally. So the data rates are there. You can't change them. You can't optimize them. You won't be able to do anything about that. And not only that, like I said, you won't be able to reorder if you have to give priority to something. So you just have to be clever about it and accept it the way it is.
Hi. I'm wondering, maybe there is some kind of open source library or something like that that could somehow a little bit simplify that API and the Bluetooth layer, because you mentioned that a lot of corner cases and you need to deal with them, and not all of them are clear enough.
Okay. There's two things I can tell you. First of all is the pairing scenarios and whatnot. It doesn't matter what code you write because it's not up to you. Like you can't read the state, right? Like I didn't put it here, but if you look into CB peripheral, it will tell you the peripheral is connected. It's a logical connection, but what connected really means, right? I just showed you that you can have the did connect callback and you don't have the keys. So you have to ascertain if you have the keys or not. So going back to your question, I would say you can look for YS Bluetooth. There's some block-based approaches to it. But again, this is just about manipulating the code and let's say how you look at it. Let's say how you handle this. It's how you structure it. But the corner cases are there. I mean, seriously, what can you do? It's how you get informed. If there's no way to detect you went out of range, or if the device has been removed from the pairing table, there's no code that can substitute that. You won't get informed, so you have to be smart about it. In our scenario, for instance, one of the things that we had to do is we can't detect classic connection, right? We're not MFI compliant. We're not enrolled in that. So what we had to do is we ping through the BLE connection, the device, and we say, do you have a classic connection to me? And you reply, yes. So it's like, I'm connected to you. I'm like, am I connected to you? And like, yeah, you're connected to me. I'm like, good, nice. Let's talk then. It's pretty crazy, right? But that's how it is. I mean, I don't think you could get away from that. Come on, people, Bluetooth is fun. Nothing else? No one? No brave warrior? All right then, so thank you very much, and I hope you've enjoyed it.